Hello friends, this video on electric charges and fields part 3 is brought to you by ExamFear.com. No more fear from exam. So we will here in this section talk about charging by rubbing. How can we charge an object simply by rubbing it against another object? So we will talk about how insulators can be charged by rubbing. Now just have you ever observed this phenomenon, or if not, just try it out yourself. All you need is a plastic comb, and you would observe that if your hair is dry enough and you are combing your hair, fine, for some time, and after that you take the same plastic comb and bring it near few tiny pieces of paper. So maybe let's say that you bring it near a table, and on the table you just keep some very tiny pieces of paper, and a magical thing happens. You would see that these papers, they tend to get attracted towards the plastic comb. Now we all very clearly know that plastic, either plastic or paper, they do not have any such property by which they would attract each other. But what happened, or what change happened just after the comb, after you combed your hair using the plastic comb? The more interesting part is that if you try to perform the same activity using a comb which is not made up of plastic but made up of wood, the wooden comb will not show this magical thing. So that means this attraction between the pieces of paper happens with plastic comb, but this doesn't happen with a wooden comb. Now the question is, first of all, why at all this happened? How the plastic comb was able to attract the pieces of paper? So that's the first question that we have to answer. The second thing is, when it happened with the plastic comb, why it didn't happen with the wooden comb? Now here, as a matter of fact, we all know that both wood as well as plastic, so either wood or plastic, they are poor conductors of electricity. That is, the electrons in them are bound to their parent atom so strongly that they do not really have free electrons. Now, any object which is a good conductor of electricity, why is it a good conductor of electricity? Because it has free electrons, because it has charge carriers. So there is somebody who can carry the charges, and the flow of charges constitute current. So for electricity conduction, there has to be some free electrons who would be able to carry the charges. But in case of both wood or plastic, their electrons are very strongly bound to the parent atom, so therefore they are not free to move. So they are poor conductors of electricity. Now the question is, now since we can very clearly see this attraction, this shows that there is some kind of charge on this plastic comb. How that charge came and how this entire process happened, that we still don't know, but there is some charge over the plastic comb, because of which it is attracting the pieces of paper. So this phenomenon basically happened as a result of static electricity. So here we introduce the concept of static electricity, because normally whenever we talk about electricity, all that comes to our mind is the current electricity, that is the flow of electrons through wires or through good conductors, and that's how electric current flows, and that gives rise to current electricity. But here we are talking about a different concept altogether. It is static electricity. So let us understand what happens in static electricity. So here we really do not have flow of current throughout that material. Rather, it is all about building up of electric charges on an object. So basically, when some extra charges or some excess charges accumulate over the surface of an object, so that gives rise to static electricity. So still that object is a poor conductor. Maybe inside, through that object, there is no conduction of electricity, but due to some external process, some excess of charge developed, or they accumulated over the surface of that object. Therefore, static electricity is a purely surface phenomenon, because it has to do only with the surface. Nothing happens inside the object. Now this charge which gets accumulated on the surface, they can either suddenly discharge or can stay for some time to make the objects attracted to each other. So this is like a temporary accumulation of charges, you can say. Now, because now you understand what might have happened with the plastic comb. So there would have been some excess of charges over the surface of plastic comb, because of which it was attracting those bits of paper. So all we understand is static electricity is all about charges being collected on the surface of an object. Now, some materials cause or create more static electricity than other materials. Now, let us look at some materials. Now, there will be certain group of materials who will have a tendency to lose electrons. There will be certain materials who will have a tendency to gain electrons. Now, as we all know that those materials which tend to lose electrons, they become positively charged, because now they have lost electrons. So, electrons are always negatively charged. So when they have lost electrons, that means they have less negative charge, or they have more positive charge. So they become positively charged. Similarly, the materials which tend to gain electrons, they tend to become negatively charged. So here are a list of materials which have a tendency to lose electrons. So materials like the dry human skin, or human hair, or silk, or nylon, or paper, or glass, wool. So these are all examples of materials which have a tendency to lose electrons. Now they have a tendency to lose electrons. So once they lose electrons, what will happen? They will become positively charged. So all these materials fall in this category where they tend to become positively charged. What about those materials which have a tendency to gain electrons? So those examples would be plastic, which might include PVC or polyester, hard rubber. So these are examples. Plastics, rubbers are examples of materials which have a tendency to gain electrons. And once they gain electrons, they tend to become negatively charged. Now the question is how this transfer of electrons will take place. So that is what happens when we rub two objects. Now when we rub two objects come in physical contact with each other. Basically the surfaces of the two objects come in physical contact with each other. So as I said, static electricity is all about surface phenomena. So on their surfaces there are certain exchange of charged particles. So electrons might move from one object to another. So the one which loses electrons become positively charged. The one which gains electrons become negatively charged. So something of this sort actually happens during rubbing. Now there are a certain set of materials as well which stay neutral. They do not have they neither have a tendency to lose electrons, nor do they have a tendency to gain electrons. So they are like almost neutral. So few examples of such objects are cotton, wood. So these are objects which tend to be almost neutral. Now here I would like to mention an example. Now have you ever seen that if you wear cotton clothes, in that case you never experience static electricity. But if you wear synthetic clothes, maybe silk clothes or rayon clothes, so if that's the material of your clothes, and if your skin is very dry, when you touch your cloth, you tend to get a shock, or you tend to see a spark. So how does that spark or that shock happens? That happens due to static electricity, because in cotton clothes it doesn't happen, because cotton is neutral as far as losing or gaining electrons is concerned. So cotton really do not get charged. But when you talk about silk or rayon or polyester, they tend to build some excess of charge. For example, if it is silk, it will have a tendency to lose electrons, so it will become positively charged. So whenever it comes in contact with some other object, there might be some attraction, there might be some experience of electric shock. So all these things happen due to those static charges over the surface of the object. So this is about the concept of static electricity. So having known this, let us try to understand what exactly happens during rubbing. So we will again take the same example, and we will try to understand how rubbing of insulators cause transfer of charge, because this transfer of charge actually leads to that entire phenomenon of attraction of the comb and the pieces of paper. So what happens when we comb our hair? So here, what are the two objects which are in physical contact? So the two objects are human hair and the plastic cone. Now, in the previous slide, we saw that human hair has a tendency to lose electrons and plastic has a tendency to gain electrons. So that is by their property, that is by their nature. So they tend to lose electrons and they tend to gain electrons. So what would happen? So when they are in physical contact with each other, when you are combing your hair, what is actually happening is electrons are lost by the human hair, which in turn is gained by the plastic comb. So basically transfer of electrons are taking place from human hair to the plastic comb, right? Okay, now what happens when the human hair is losing electrons? So any object which loses electrons tend to become positively charged. And any object which gains electrons tend to become negatively charged. So the plastic comb is getting negatively charged, whereas the human hair gets positively charged. Now I'll give you an evidence that human hair gets positively charged. Now before combing your hair, your hair strands were like proper and straight. But you would have observed that when your hair is dry and you comb it with a plastic comb, and you would see that the strands of your hair, they tend to fly away from each other. So they kind of repel each other because all the hair strands, they are positively charged, and positive repel each other. Therefore the hair strands, they tend to move away from each other. So just try this out yourself. The moment you comb your hair, when your hair is dry, the hair strands, they tend to fly away from each other. So that happens due to repulsion, because your hair has acquired positive charge and like charges repel each other. Okay, so that's why the human hair got positively charged. And what about the comb? The comb acquired negative charge. Now this phenomenon can also, not only with plastic comb, this can also happen with a rubber comb, because as we saw that hard rubber also has a tendency to gain electrons. Fine. Now in the second part of this activity, what we do, we take that plastic comb which is now negatively charged. So it is no more neutral, it has a negative charge over it. But these negative charges are those excess electrons which are present only over the surface of the comb. Now this plastic comb comes in contact with these pieces of paper. Now these pieces of paper, so do they have any charge? They are neutral. Right now they do not carry any charge. But we know that whenever you have one charged object and one neutral object, so they tend to attract each other. Correct? So therefore in this case what happens? There would be attraction because the comb has acquired a negative charge. So the charged plastic comb tend to attract the neutral pieces of paper. Fine. So now we understood that why this magical thing happened. Now the question is, why the same thing did not happen with a wooden comb? So let's try to understand that as well. Now in case of wooden comb, when you are combing with your hair with this wooden comb, so basically the human hair in that case is in physical contact with the wooden comb. Now, what is the property of wood? As we saw that wood is almost neutral. And human hair has a tendency to lose electrons. But the wooden comb being almost neutral, it doesn't have a tendency to gain electrons. So therefore, proper transfer of electrons cannot take place in this case. And because of that, there is no static electricity. Therefore, the wooden comb is not charged, and as a result, it does not attract the pieces of paper. So, this kind of charging which I am talking about, the charging by rubbing, which happens in case of insulators, but how much charging will happen also depends on the nature of the insulator. For example, here wood is an insulator, paper is also an insulator. But in case of paper, it got very easily charged. Right? Because it is in the property of paper that they tend to gain electrons. But in case of wood, since they are almost neutral, they tend to gain very few electrons. Therefore, the development of static electricity or the accumulation of charges over wood is comparatively lesser than that of the plastic. So that is why in wooden comb you do not see this phenomenon very evidently. but it is very evidently seen with a plastic or rubber cone. So this experiment very clearly proves that if we rub insulators, transfer of charges take place and these charges accumulate over the surface of that object, because of which that object gets charged, either positive or negative charged for a while, and because of which we see all these interesting phenomena. So charging can happen by rubbing in case of insulators. Now you might ask, what about conductors? Why do we say that charging can happen by rubbing only in insulators and not in conductors? So let us try out another experiment. So now we replace the insulator with a conductor. So here we have a towel and you take a metal key. Now metal, as we know, is a good conductor of electricity. That is, they have enough free electrons which can conduct electricity within them. So now when you take this metal key and you rub it over the towel for quite some time, maybe for a couple of minutes altogether. So what should happen? Now, like in case of insulators, after being rubbed for some time, the insulator or that object acquires charge. But in this case, what happens, the key does not acquire any charge. And how do you know that? If you take the same key near some other object, you see that there is no attraction, it just falls to the ground. But had you repeated the same experiment with some insulator, maybe with a piece of balloon, with a balloon which is made up of rubber, so in that case you would have observed something different. But here with this metal key, there is no charging that has happened. Now, can you say why? Why is no charging happening in case of a conductor? Now, insulators can hold electric charge on their surfaces, but conductors cannot. Why? Because they conduct. Because conductors, they already have a lot of free electrons. The moment they have some extra charges, they tend to get conducted through them. So, they conduct the charges so quickly that there is hardly any time for any appreciable charge to build up on their surface, because the charge really do not stay on their surface. The moment it comes to their surface, it gets conducted through the free electrons. So there is no excess charge accumulation over the surface of conductors. Therefore, the concept of static electricity, or that this development of static charges, this really doesn't work that well with conductors. Especially when we talk about charging by rubbing, that really doesn't happen in case of conductors. So based on whatever we have discussed in this section, we understand that by the process of rubbing, what we do is we can charge the insulators, because during rubbing the surface atoms are pressed together, because of which the electron clouds of those atoms, like let's say these are two atoms. So this is one atom, this is another atom. So there would be, there inside the atom you have the nucleus, you have the electron clouds like this. Now when you bring these two objects in physical contact with each other, the electron clouds, they tend to interact with each other, which results in transfer of electrons. Now these transferred electrons, they are not very stable and they just remain on the surface of the object for some time. As soon as they get some contact, these electrons tend to get lost. So that is why the static electricity that happens only due to temporary buildup of charges over the surface of an object. So, and this concept is not very clearly seen in case of conductors, because they tend to conduct. Therefore, this concept of charging by rubbing can happen only in case of insulators, but not conductors. Thank you. Please visit ExamFear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.